Okay, here's a quick look at, got to get you guys started. If you're watching this, either you're watching it at home or I am gone for the morning because I'm off at this awesome meeting, but make the most of this as you can. What I'm going to do is going to kind of work things kind of in the backward order. I'm going to show you some skills related to these things called matrices. Now, we've talked a little bit about I don't know if you guys have ever mentioned matrices when you're in Algebra 2, but it's a way of organizing systems of equations. And so really what's inside here, depending on how you set it up, is like there's systems of equations like this would be 5x plus 1y, and the one down below here would be like negative 1x plus 0y, and this would be 2x plus 3y. This would be like a system of equations. What these are, these particular matrices, sometimes we remove what they're equal to, because there might be something like they're equal to 5, this one's equal to 5, this one's equal to 0, and so on. And systems of equations, we sometimes include that part in our matrix. Sometimes we don't. But in the matrix itself, all we really care about are the coefficients, the numbers that go with the x and the y, and sometimes z and w and other variables too. So that's just the basics of where we use matrices. It's to organize systems of equations and to do other really cool stuff. So matrices are hugely powerful. They're used in a lot of computing calculations. If you're doing lots of data or lots of equations and you want to do quick computations on it, the way to go is get out these matrices and go to town. So I'm going to show you just some matrix operations to get you familiar with it, and then later on we'll go back and tie in the old systems of equation stuff. But this is just some skills things, and you guys are good at this kind of thing, so I thought I'd give you a little intro that way. All right, to multiply matrices, that's what that dot in the middle is all about, is to multiply these. Well, multiplying matrices is not just straightforward, you just don't go straight across. So I want to start with that. What you actually do is you take this negative 2 and this negative 6, and I'm going to take it over here, and I'm going to multiply it by, I'm going to turn it on its side. So let's imagine I took this negative 2 and negative 6, or negative 2 and 6, and what I'm going to do is multiply it to these two terms over here. So what I'm going to do is take each of these in the right-hand matrix, each of these pairs, the vertical pairs, I'm going to turn them sideways and multiply them by these horizontal pairs in the other matrix. Now, just watch how this unfolds. I do it repeatedly, and there's a pattern to it, so you just want to hang tight while I unfold that pattern. So here goes. I'm going to back up just a little bit, and then I'm going to unfold this down underneath. The way this works, also, the end result, this is what I'd call a 3 by 2 matrix, this first one. And we do it by rows, by columns. So rows would be 3, columns would be 2. And then this over here on the right-hand side, this would be a 2 by 3 matrix, because it's got 2 rows and 3 columns. When I multiply a 3 by 2 matrix by a 2 by 3 matrix, the result is a 3 by 3 matrix itself. And so what happens, and I always like to think of it as my those overlap, that right there, first of all, you can't multiply them unless there's an equivalent overlap, by the way. So these must be equal for this multiplication even to work. And then what happens is you eliminate those and you end up with whatever's on the end, a 3 by 3 matrix. If this was a 5 by 2 times a 2 by 6, we'd have a 5 by 6 resultant matrix after multiplication. So that's the process of multiplication and how it looks. Because I know that, I'm actually going to set my stage, and this will help you understand how to do multiplication with matrices. I am going to multiply these two together, and the result is going to be a 3 by 3 matrix, 3 rows and 3 columns. And I might simplify it in another step on another page here, but this is the look. I'm going to fill in each of those blanks. It goes like this to start with. I'm going to go with red because you'll be able to see it stand out. I'm going to take that first column on the right hand, I'm going to take this one and multiply by the 5 by 1, or the 5 and the 1, and it looks like this. I'm going to take the negative 2 times the 5. I'm going to make this as big as I can. So the negative 2 times the 5, I'm going to add that to the product of the 6 by the 1. 6 times 1. Okay, so that's the first part of it. That's actually my first entry, is the product of the first two terms in that right-hand matrix by the first two horizontal terms in the left-hand matrix. You do their product of each component individually, and we add them together. Okay, so then the next one, I'm going to take this next column of values, the 3 and the negative 1, and also multiply it by the 5 and the 1. So this will take 3 times 5, and then I'll take the negative 1 times 1. I'm going to add that. You're going to see a pattern when this is all said and done, so it'll look a lot better when you're done. That becomes my second entry in all of the 9 total I'm going to get in here. And then the last one will be 4 times 5 plus 2 times 1. Okay, those are my first. So I took the first 3 vertical rows times just that first set of horizontal pair on the left-hand side. Those are the results for my first row. Now guess what's going to happen, how I'm going to create my second row in my resultant matrix. I'm going to take, imagine these vertical columns one by one, but I'm going to take them and multiply them by negative 1 comma 0 now. So I'm going to erase that little thing up there. I'm going to clean this up so you can kind of see where I'm going one by one. So now we're multiplying each of these vertical columns times the middle horizontal pair. So that's negative 2. That's the vertical component times that negative 1. Oops, didn't get a 1 in there, did I? So let's back that up. There we go, negative 1. Plus, I'm going to do my 6 times 0. Okay, so that's the end result of that. And then over on, we're going to do the middle vertical pair times those, so 3 times negative 1. And looks like that. And then negative 1 times 0. The negative 1 times 0. Now I want you to notice something on here. I'm going to highlight a little. Notice that I'm using the same 6, negative 2 and 6. I'm just using the same 3 and the same negative 1. Those are the vertical pairs. That's me multiplying by the same pairs over and over again. So if you notice that pattern, great. If you don't, that's okay too. It'll come. As you do more, you get the pattern as you go along. And then the last one is I'm going to take this last vertical pair, 4 and 2, times the negative 1, 0 pair inside. So I got 4 times negative 1. Remember I did 4 before. That's cool. And then 2 times 0. There. And then at the bottom, guess what? We're going to deal with the bottom pair down here. So that's negative 2 times negative 2. So there's that negative 2 again. I'm sorry, times positive 2 plus 6 times 3. That'll give me that result. The middle one, I'm dealing with 3 and negative 1 times the bottom, so it'll be 3 times 2 plus negative 1 again times 3. And then last one, 4 and 2. So we're going to do 4 times 2 and then plus a 2 times 3. That's it. We filled in the matrix. Now we just have to do all the simplification stuff. So each of those we can turn into a particular value. So the end result matrix, I'm going to just write off to the side here just so you can kind of see it all in action. I'm going to do blue again here. So my 3 by 3 matrix in the end for this one is the result of each one of these. So negative 10, that's the 2 times plus 6 is negative 4 for that first value. 15 minus 1 is 14 for that middle top piece. 20 plus 2 is 22. Negative 2 times negative, that's 2 plus 0 is 2 in the middle left. Very center is negative 3 plus 0, so negative 3. The far right, negative 4 plus 0 is negative 4. And then the bottom left is negative 4 plus 18. And we get 14. Okay. And then 6 minus 3, and that bottom middle is 3. And 8 plus 6 is your 14, the final entry on the last one. That's it. That's the product of these two matrices is down below here. So sometimes we like to label these. I'm going to get a nice bright color, something that would be, let's do nice highlight. Let's do that pink. That pink's always nice. So pink highlighter. This would be like matrix A, and this would be matrix B. We would say this is the product. This would be A times B down here, that end result. Okay? So that's part 1. There are other simpler multiplication with matrices. Kind of takes a while. That's probably the most time-consuming one. Cool thing is we can pull out a calculator and it'll take care of it for us. I will do that a little later, but in the meantime, that's just the introduction to the skill. This is recorded so you can watch it hundreds of times if you desire. Now I'm going to make room. I'm going to do this scalar piece over here on the side, number 2. This is called a scalar again. Now we've dealt with scalars when we're doing vectors, and in fact, matrices and vectors, you can represent vectors in matrix form. So interestingly enough, a lot of the operations we learn with vectors, they work the same way within matrices. That's scalar. This is really nice. All we're going to do is multiply each term in the vector by that scalar. So what we end up with is by multiplying by the scalars, we're going to have two subtracted, let's see, there's two added matrices. The first one makes -6. I hope you can follow where I'm getting these from. I'm distributing, and that's +4 and then 0. And then -2, -8, and -6 after distributing the -2 to all the terms on the left matrix. I'm going to distribute a -4 so I can make it plus. I really like having plus involved, or a positive if I can. So I'm going to make this -4, I can make this -12, and I can make this last one here, if I can make that big enough, -8, if I can get in there. Good. And then the last one, of course, times 0 is still 0. Make this +16, and I'll make this -4. Now, I distributed the negative with it, so that's why now it's plus between these two matrices. Matrix addition, you're going to love. You can only add matrices that are of the same side. This is 2 by 3, and this is 2 by 3. They have to line up tit for tat, so you got to have same rows and columns to do matrix addition or subtraction, which is just adding a negative. When you do subtraction, you can think of it as just adding a negative. There is component to component. I just do -6 minus 4, so -10 is the result in the upper left, and then 4 take away 12, -8, and then 0 take away 8, -8 again, and then -2 and 0, the lower left components make -2. -8 plus 16 is 8, and then -6 plus a -4 is -10. Okay, so I distributed the scalar, then added them component to component. There's the end result. That's how scalars are treated in matrices, and that's how matrix addition or subtraction works, piece for piece. Then at the end here, we're getting close to we're going to talk about determinants. Well, determinants are like when we were doing dot products with vectors. It's itself not a particularly interesting, it gives you a single value, just like the dot product did, but it also isn't by itself useful. It's just a common operation when you're dealing with matrices that gets a special name. It has special uses when we're doing other calculations, so it just gets a special name. The way you do the determinant of a 2 by 2 matrix, which is kind of the root of all determinants, it all comes down to the 2 by 2 matrix. What we do is we take the difference of the cross products in here, and that's your determinant. It's about as simple as that. So if I do the blue one, and you have to do this one first and this one second, so the left one first and the right one second, the way I'm looking at it anyway. So -1, watch this, times 6, the product of that first diagonal from the upper left, you start at the upper left, minus the product of the other two, which is 5 times 2. And there you go, that's going to be that's our determinant. And that's -6 minus 10, -16, done. No value except that it's useful, a common value that makes other things useful, other operations possible. The basics of a 2 by 2, so it starts with upper left first, we do that, get that diagonal product first, and then we do this one second, and we get our determinant of 5 times 7. That's the first minus 3 times -2. And so it's 35 plus 6, 41, and that's our determinant for that 2 by 2 matrix. Larger matrices, like this other, and by the way, you can only do determinant of square matrices, so they have to have the same rows and columns, so 2 by 2, 3 by 3, 4 by 4, etc. The 3 by 3 matrix, this one's a little bit more complicated. What happens is we don't actually, what we're going to do is turn it into a sum of, in this case, since it's 3 by 3, 3 2 by 2 matrix, 3 2 by 2 determinants. So if I set this up for you, maybe you can follow the pattern in here, but the numbers in the middle, that middle row column, don't actually end up in the determinant pieces. They end up treated a little bit differently. So I'm going to color those each a little differently. And this one's a pattern that takes a little bit of getting used to. So hang tight and be patient here. That -1 is part of my process, that first -1, the blue one. And then there's a determinant, a 2 by 2 determinant that I'll show you how to calculate in a minute. And then there's the red -1. That's going to go here next to this determinant. And then there's going to be the green one. So we got the green 1, literally the green 1. Okay, so those are going to be our, I guess I could take that a little bit wider. I got more room than I thought.